Welcome to myprojectbazaar.com. Our project title is Asthma Pattern Identification via Continuous Diaphragm Motion Monitoring. Now we discuss about the abstract of our project. Our project abstract is ultrasound imaging has been widely used in the biomedical imaging diagnosis for a long history. Because of its metrics, no radiation, high penetration, depth and real-time imaging capability. In this process, we are proposing an ultrasound-based system that monitors the respiratory status of the asthma subject via the detection of particle movement. This system implements Canvas algorithm to accurately segmenting the diaphragm area from ultrasound image, sequencing and extracting the 1D breathing waveform by computing the mutual information between the two consecutive ultraframes. In addition, 4 types of respiratory signals are identified, which are related to 4 symptoms of asthma attack and identifying the breathing templates used for yearly asthma detection. In experiments, the proposed system is evaluated with the public dataset from the ultrasound imaging gallery, which containing the ultrasound video and our dataset collected by an Interson C-mode probe, which containing 5 ultrasound video in the diaphragm area. And the ultrasound video is converted into frames. Then the frames are added in our process. The results shown that the sandwich segmentation algorithm method is superior to other 3 algorithms: adaptive thresholding, EM and fuzzy C-means clustering. MI is feasible method to extracting the accurate respiratory signal and clear information of the phase of respiratory cycles from 2D image. Now we are going to discuss about the flow of our project. First module is input image. Here we take one input image, then goes to the pre-processing stage. In the pre-processing stage is used to removing the noises. In this process, the pre-processing is carried out by the 2 major methods like noise removal and image enhancement. Image enhancement is the process of adjusting digital images so that the results are more suitable for displaying or further image analysis. For example, you can removing the noise, sharpening or brighten an image, make it is easier to identifying the key features. Digital images are prone to variety of types of noise. The noises is the result of error in the image acquisition process that result in the pixel values that do not reflect the true intensities of the real scenes. There are several ways that noise can be introduced into an image. It depends on how the images is created. Next one is a segmentation. In the segmentation process is implemented using a Canvas active contour method. While many segmentation methods rely heavily in some way on edge detection, the active contour without edges method by Chan and West ignoring the edges completely. Instead, the method optimally fits the two-phase piecewise constant method to give image. The segmentation boundary is represented implicitly with a level set function which allows the segmentation to handling topological changes more easily than the explicit snake methods. This process describing the level set formulation of a Canvas active contour method and its numerical solution using a semi-implicate gradient descent. We are also discussing the Canvas active contour method in the image. Next one is a feature extraction. The image features are converted into a signals. The signals extraction is done using the fast Fourier transformation method. The fast Fourier transformation FFT algorithm computing the DFT of a sequence or its inverse. Fourier analysis converting the signal from its original domain to a repository in the frequency domain, vice versa. On FFT results is managing to reducing the complexity of computing the DFT. The FFT is complicated algorithm and its details are usually left to those that especially in the such things. This sections describing the general operations of FFT put a strict key using the uses of complex number. Next one is a classification method. We are using the SVM classification to finding the four types of disease. The machine learning pattern recognition and the image processing, feature extraction sort from the initial set of measurement data and building the delivers values, that is features intended to be informative and non-redundant, facilitating the sequence learning and generalization step, and in some cases leading to better human interpretation. Feature extraction is related to a dimensionality reducing. When the input data to the algorithm is too large to be processed and it's suspected to be a redundant, the sum of measures in the both the feet and the matters or repetitive of image presents as pixels. Then it can be transformed into a reduced set of features, also named as a feature vector. This process is called a feature extraction. The feature extractions are expected to containing the relevant information from the input data, so that the descriptive task can be performed by using this reducing the representation instead of the computer initial stage. Then the performance measures is used. The accuracy, sensitivity and specificity of the classifier is measured, and the accuracy represents the efficiency of the process. The sensitivity shows how the algorithm gives the correct classification. The specificity shows how the algorithm rejected the wrongly classification results. We designed a spatial consequence constraint in the graph model to improve the detection performance. Now I am going to explain about the output of our project. Our project developed in MATLAB 2013 version. Go to the current folder and select main.m file. Right click the file, select run button. Now run the project. Now I am going to open the dataset folder and selected one image. 15.jpg image is selected. Now run the project. First input image is resized. Then filtering is applied. Then after the filtering, the segmentation is done. Then the converting the signal. This is input image. This is pre-processed image. The input image is resized, then removing the unwanted pixels in the image using the Gaussian filter, then median filter. The median filter result is used to the segmentation stage. The affected and non-affected region is segmented here. Then the values are converted into a signals. The signals features values are extracted here. The statistical features is find. The multi-energies, eigenspace, mean, variance, median, entropy, minimum amplitude, maximum amplitude, energy, frequency, phase, that are finded here. Then classifying the output, and the performance measures graph is displayed here. This graph represented the accuracy, sensitivity, specificity of the algorithm. Then precision and record is displayed here. Thank you for listening. Our demo is completed.